isostasy. This is the concept we will be discussing today. The Earth's surface is made up of different relief features such as mountains, plateaus and plains, as well as seas and oceans standing on the rotating Earth's surface are probably balanced by certain principle, otherwise would not have maintained in their present form. Different reliefs are made up of rocks with different densities. The question which arises here is that what is the principle of balancing? When all the relief features have different densities, how the Earth can sustain the equilibrium position? How the balance between various surface feature is maintained? Is the equilibrium or balance between various surface features is constant or permanent in nature? How isostatic adjustment takes place? And so on. Geologists have different perception, views, answers and explanation. The answer to these questions can be provided by the concept of isostasy. Hence, an understanding about the concept of isostasy is essential. With this background, the basic idea of this lesson is to understand the conceptual evolution of the theory of isostasy, to bring out the basic assumptions of the theory of isostasy, to know the various concepts in support of the theory of isostasy. The concept of the theory of isostasy grew out of the gradual thinking in terms of gravitational attraction of lofty mountains masses. Perry Bauger, during his expedition of the Andes mountain in the year 1735, found that the tall volcanic peak of Chimborazo was not attracting the plumb line as it should have done. He observed that the gravitational attraction of Andes mountain is much smaller than that to be expected from the mass represented by these mountains. Similar discrepancies were noted during the geodetic survey of the Indo-Gangetic plain. For the determination of latitudes under the supervision of Sir George Everest, the then Surveyor General of India, in 1859, the difference of latitude of Kalyanpur and Kalyana was determined by both direct triangulation method and astronomical method. Kalyana is located closer to the Himalayas than the Kalyanpur, located 96 kilometers away from Himalayas. The difference between these two methods was 5.23 seconds. The discrepancy between these two methods was attributed to the gravitational attraction of Himalayas, due to which the plumb boss used in the astronomical determination of the latitude was deflected. The difference or the anomaly, according to the scientist, is attributed to the enormous mass of the Himalayas, which was responsible for the attractional force and therefore for the difference in the result of the two methods. This attraction was the cause for the error. Later on, this matter was referred to Arkadikian Pratt for further investigation and clarification. Pratt estimated the amount of attraction of the Himalayas on the basic assumption that all the mountains had the average density of 2.75. Pratt, based on the minimum estimate of the mass of Himalayas, calculated the gravitational effect on the plumb bob of two places, that is Kalyana and Kalyanpur, and to his dismay, he discovered that the difference was surprisingly more than the actually worked out during the geodetic survey. The difference calculated was 15.885 seconds. Thus, the difference of 15.885 seconds was 3 times more than the observed deflection of 5.236 seconds during the survey. Pratt's calculation of the difference of gravitational deflection brought another fact before the scientists, that Himalayas were exerting attraction according to its enormous mass. This interpretation gave birth to another problem. What is the reason behind the low attraction of Himalayas? Pratt's calculation of the difference of the gravitational deflection brought another fact before the scientists that Himalayas were not exerting the gravitational attraction according to its enormous mass. The interpretation gave birth to another problem. What is the reason behind low attraction force of Himalayas? The rocks of the Himalayas are of low density and thus their gravitational attraction is also low. Due to low density, their total weight would be low and consequently the gravitational attractional force would also be low. If the mountains are not hollow, the visible mountain mass must be compensated by deficiency of mass below. In other words, the density of the rocks of the mountain must be relatively low down to considerable depth. Thus, the total weight would be low and consequently the attractional force would be low. It was suggested that there is such a level below the surface of the earth below which there is no change in the density of rock. Density varies only above this level. Thus, all the columns have equal density along this level. It was therefore suggested on the basis that bigger the column, lesser will be the density, and smaller the column, greater will be the density. Discrepancies of the gravitational deflections or the anomalies of the plumb bob and the resulted into the postulation of the concept of isostasy by various scientists. The view of few of them are presented here. Isostasy simply means a mechanical stability between the upstanding parts like mountains and plateaus and low-lying areas like plains and ocean basins on the rotating earth. The state of balance which the earth's crust tends to maintain is known as isostasy. The gravitational adjustment of the earth's crust is isostasy. The word isostasy is derived from a Greek word isostasios, meaning equipoise or equilibrium or state of balance. In Greek, the term isos means equal and stasis means standing. The term isostasy was first proposed by American geologist Dutton in 1859 to express his views to indicate the state of balance which exists between large upstanding areas on the earth's surface like mountain ranges and plateaus. According to Dutton, the upstanding parts on the earth like mountains, plateaus and plains and ocean basins must be compensated by the lighter rocks from the material from the beneath so that crustal relief features remain in mechanical stability. The concept of isostasy is based on the concept of buoyancy. Buoyancy is the ability of an object to float in fluid equal in mass to the floating object's own mass. The concept of isostasy is based on the principle of buoyancy, first outlined by Archimedes. A ship with a cargo floats because it displaces the volume of water equal in weight to its own weight plus the weight of the cargo. As the empty ship without cargo displaces smaller volume of water than the ship which was loaded with cargo. The water supporting the ship is not strong in mechanical sense. It is the buoyancy rather than the mechanical strength that supports the ship with cargo. Similar analogy can be extended to the earth's surface. Isostasy occurs because the crust is more buoyant than the denser mantle beneath it. Each portion of the earth's crust displaces the mantle according to its thickness and density. Denser the crustal material sinks in deeper into the mantle than does less denser crustal material. Alternatively, thicker crustal material will extend to a greater depth than the thin crust. Isostatic adjustment of the Earth's crust can be compared with the adjustment of a sheet of ice floating as you skate on it. A layer of ice bends beneath you, displacing the water, displacing a volume of water with the weight equal to our weight. As you move ahead, the ice rebounds behind you and the displaced water flows back. Similarly, as a result of isostatic adjustment, high mountain belts and plateaus and commonly underlain thicker crust that extend deeper into the mantle than the areas of low elevation like plains and ocean basins. Isostasy occurs because the crust is buoyed by the denser mantle beneath it, and each portion of the crust displaces the mantle according to its thickness and density. Denser crustal material sinks deeper into the mantle than the less denser material, and the thicker crustal material with extend greater depth. The concept of isostasy, therefore, is fundamental to the studies of Earth's crust's major features like continents, ocean basins, mountains, plateaus and plains, and to the understanding the response of crust to erosion, sedimentation, glaciation, etc. In brief, the concept of isostasy depends upon the model of the Earth's crust in which lighter continental masses float on the denser substratum. According to Steers, 1961, this doctrine of isostasy states that wherever equilibrium exists on the Earth's surface, equal mass must underline equal surface area. The concept of isostasy is conceived differently by different scholars. The view of some of them are discussed here. Airy's concept of isostasy is related to the concept of flotation. The idea of Airy views is uniform density with varying thickness. Airy postulated his view with the help of an illustration of wooden blocks of different lengths floating in the water. All the blocks of uniform density but different heights. It is seen that the block which rises much above the water is also the block which goes deepest into the water. The blocks sink to different depths depending on their length. These blocks are said to be in state of hydrostatic balance or equilibrium. Airy assumed that the continents are made up of lighter material. Seal or continental blocks are floating as lighter blocks over seema, which is made up of denser material. The sealic blocks are of equal density. That is, the continents are made up of rocks having uniform density. Similarly, when this concept is viewed from the point of view of different landforms on the Earth's surface, such as mountains, plateaus, plains, etc., it is assumed that land masses are composed of similar density or rocks, but they penetrate deeper into the substratum in proportion to their height. Airy is of the view that the lighter seal of Himalayas is floating over denser seema. The lighter rocks of Himalayas are extended as roots deep down into seema, just as a large part of the boat remains immersed into the water. So are Himalayas floating on the denser rocks below, and the weight of the mountain is balanced by light material penetrating into seema to a greater depth. These landforms or relief features are assumed to compose of rocks with similar density, but their thickness varies. Based on the above observation, Airy postulated that if the land column like mountain raises much above the substratum or the seema, the greater part of submerge in the substratum, and if the land column above the substratum is higher, its greater part will be submerged into the substratum. It is thus seen that every upstanding part have a root below in accordance with their height. In other words, density does not change with depth, that is uniform density with varying thickness. The important conclusion or the inference that can be drawn is that those blocks which are not raised above the liquid are also not much submerged below. Therefore, that there are irregularities in terms of height above the floating medium as well as irregularities in terms of depth below the floating medium. Mountains, plateaus, plains, etc. sunk to different depths in the same because they have differences in thickness. Pratt computed the data obtained from the trigonometrical and geodetic survey of Kalyanpur and Kalyana. According to him, the gravitational attraction of Himalayas was less than the mass represented by Himalayas because the Himalayan mountains are made up of lighter material, that is, the rocks are of much lower density. Pratt stipulated that rocks of the mountain chain should have lower density than those of the plateaus, and the rocks of plateaus lower than the plains, and the plains lower than the rocks of the ocean floor. In other words, the elevated areas like mountains and plateaus are made up of rocks of lighter material, and the rocks associated with the low-lying areas like plains and ocean floor are made up of denser rocks. In his opinion, there was an inverse relationship between the height and density. Pratt visualized that there was a level above which these density changes are found, and below certain level the density is uniform. Pratt's concept of isostasy was related to the law of compensation and not to the law of flotation. According to Pratt, different relief features are standing only because of the fact that their respective masses is equal along the line of compensation because of their varying density. According to Pratt, there is a level of compensation above which there is variation in density of different columns of the land like mountains, plateaus, plains, but there are no changes of the density below this level. Density does not change within the column but changes from one column to another column above the level of compensation. The relative density of mountain is 2.6, that of plateau is 2.7, coastal plains is 2.8, and that of ocean basin is 3.0. According to him, the relative density of the mountains, plateaus and plains is not the same. The mountains have lower density than the plains. The land blocks in the form of mountains, plains, etc. are floating over seema. According to Pratt, the differences in the height of the surface features is due to the differences in their density. According to him, mountains are made up of less denser material and therefore the gravitational attraction is less. The density of rocks associated with plateaus and plains is higher and therefore occupy relatively low-lying areas. The density of higher blocks is lower and that of lower blocks more. Thus, the central theme of the concept of Pratt is uniform depth with a varying density. All the blocks sank into the floating medium by equal depth, but the height above the unsunk portion were different. The relative density of zinc block is 7.1 and that of platinum is 21.50. It is obvious that the relative density of platinum block is 3 times greater than that of zinc. Hence, the exposed portion of the height of the block above the floating medium is 3 times the exposed portion of the platinum. In other words, the height of blocks above the floating medium or liquid is inversely proportional to their densities. The fundamental difference between Airy's and Pratt's view is that Airy postulated the view of uniform density and varying thickness, whereas Pratt considered uniform depth with varying density. Pratt's concept of isostasy is based on the law of compensation, whereas Airy's concept is based on the law of flotation. Airy believed in the root formation of various surface features. Pratt did not believe directly into the concept of root formation. Though both agree that Himalayas are floating in denser substratum or sima, yet there is main difference between them. Pratt believes that mountain plateaus and plains have different densities and that they sink to the same depth in the substratum. As opposed to it, Airy believes that the densities of the various surface features like mountains, plains, etc. blocks are the same, but they sink in the denser substratum at different depths. Most of the geologists favor Airy's explanation of isostasy. The term isostasy is defined as the state of equilibrium between elevated areas like mountains, plateaus, and depressed and low-lying areas like plain and ocean basin on the rotating earth. The concept of isostasy is given by American geologist Dutton in 1859. Prior to the postulation of the concept of isostasy, there were studies conducted which are related to the determination of the latitude and gravity studies conducted by Perry Bauger 1975, which is related to the gravitational attraction of Andes mountain. He observed that of the Andes mountain it is much smaller than expected. Similar discrepancies were noted by Sir George Everest during the geodetic survey of Himalayas and Indo-Gangetic plains. Later, Pratt conducted the survey and observed that differences is still more. According to Pratt, density changes from one column to another column, like mountains, plateaus and plains above certain level called as level of compensation. Pratt's concept may be expressed as uniform depth with varying density. The contribution of Airy and Pratt is enormous in the understanding of explanation of concept of isostasy.